Hey everybody, Paul Chin Jr. here, back for another episode of Talking Serverless. Talking Serverless, it's a podcast where we talk about serverless. It's not really all that deep, but today I have a really exciting show for you. We're going to be talking about databases in a higher dimension, like vector databases, and what all the hype is. And I'm really excited to bring on Jack Pertschuk from Pinecone. Jack, hey, welcome to the show. Thank you.
Hey, thanks for having me. Pleasure to be here. Excited to talk about serverless databases, vectors, and make sure you're not scared of dimensionality.
Yes, exactly. Why don't you start off by kind of giving us a quick background of what you're working on and how did you land in vector database land?
Basically, here at Pinecone, I'm focused on algorithms and platform. I was on the founding engineering team, so I've worn a lot of hats. In the early days, I even ran the LinkedIn page. That wasn't a good idea, but these days I mostly work on our low-level algorithms code, so everything that actually implements the search indexing algorithms, both for dense and sparse retrieval. We can talk a little bit about the difference of that later. And then I also oversee our research efforts around information retrieval. So we trained a re-ranker model and an embedding model, which is sort of a type of LLM designed for retrieval applications, and sort of keeping our technology on the cutting edge in terms of accuracy, precision, recall, and making sure that our customers get the search results they want when they use Pinecone as the search database.
Awesome, awesome. I guess real quick first, you do work at Pinecone, and Pinecone is a database company, right? And they offer like Pinecone DB, which is a vector database.
Yeah, so we actually sort of coined the term vector database about 4 years ago. When we started, that wasn't a thing. There were a few companies using vectors at scale, big tech companies, Facebook, Google, whatever, but there wasn't this sort of concept of a special bespoke database to handle these vectors.
Very cool. Very cool. I didn't realize that. Like many of our viewers, I watched the Fireship video, vector databases in 100 seconds, obviously. And so now I'm an expert on vector databases because I watched a 100-second video. But like I did have to do some research, and it kept leading me to this place of much higher level math than I'm used to in order to really understand the mechanics of it. But I think for the first part of our discussion, I want to try to like level against how I can traditionally think of building applications with like a database versus how I would try to think of using this vector database. Like, what are the use cases
hmm
and what are the, I guess, the models that I should have in mind? Like when I'm building, I don't know, a basic REST API, I go and I fetch prices of an item.
Yeah.
Yep, get, post, got it, cool, understand. With a vector database, is it the same thing or is it different? Like, tell me about it.
Yeah, so when you're using a vector database, in general, you're not necessarily looking for a specific detail or piece of information. Like, let's say, in your example, you want the price for something, right? This is more of an application for a traditional database like OLTP, SQL, document database, right? When customers reach for Pinecone, usually what they're building is either RAG, agentic applications that need data based on text search, right? The way models think is really like text in, text out. Okay, that's the new paradigm for LLMs. And so what it means is that when you put text into a model, you can't put that text into a SQL database, right? That text is not SQL, obviously. And getting all the relevant records is something that would require like a complicated process of transformation and all of these sort of steps. Whereas with a vector database, you can put all that text into an LLM, take a vector embedding, which is basically like an internal hidden layer of that LLM, and use that as a query, right? Instead of a SQL query, you're now using this like tensor or this high dimensional sort of machine learning model state to sort of find all related content. So it's really about search fundamentally. It's kind of similar. You can compare it to full text search in a traditional system like Elasticsearch, but it's much more accurate and much more tuned to LLM and agentic use cases.
Okay, great. So now I have this idea. Great. Okay, so it's not a transactional database or an analytical database. It's a database that is set up to I more like now I can think of Elasticsearch. Okay, with Elasticsearch, I have to have some corpus, and then I have to have Elasticsearch create the index on it, and then once Elastic makes the index, I then query the index, and then it will return whatever values like for that search, the text search in that case. But with an LLM, it's got like an even higher level of abstraction where it pulls out meaning, I guess, that like latent, what they call like latent information, right?
Exactly. It pulls out latent information from the model, which means you can model and match even more complex, like multimodal content, right? Like with Elasticsearch, okay, text in, text out, you can maybe do a search, find some related content. But by using the latent representations in the model, we can actually represent PDFs or images or all of these things in a search database so that you're not constrained by sort of traditional paradigms.
Very cool. And when developers are really saying like, okay, I've got all of these business documents that outline, I don't know, our operations, right? Step by step things. And I want to build an agentic interface for it. So a little chatbot, right? And you tell the chatbot, I have a question, how to turn on the oven. And then what happens in the vector database? Like what happens between the user saying I want to turn on the oven and then that going all the way through? Like can you walk me kind of through the transformations, like that query comes in and then it says turns it into an embedding and then sends that embedding to the vector database and then it matches a space and then it comes back and then it has to be unembedded or something, like do you think you can kind of help me understand that flow?
Yeah, exactly. I mean, I think you're really close. Your understanding is of the first part is exactly right. We get a some sort of query like, how do I turn on my oven? And then it goes and it creates an embedding, a latent representation of it that has the meaning of, oven and whatever, how, right? All of these things are encoded in that. And then we do the search in the vector database. And so generally, there isn't it's a one-way process of encoding. There's no, reversing. It's like a hash function or something like this. And so what you actually want to do, I mean, I guess theoretically you could maybe, but in practice, what people do is some sort of storage of the text alongside the vector. So they actually store the raw text in Pinecone next to the latent representation.
Oh, okay. So the when you say you store the text, that means like actual string binary goes in, not just a group of numbers.
100%. That's exactly correct.
I was missing that. I've done the what do they call them? The Python notebooks,
Notebook. Yeah,
right? You
example.
do it, and you're like, okay, cool. It gave me exactly what I thought it would do, but I have no idea what's happening.
Yeah, I think that's most people's experience because it is quite mathematical. But once you get back to basics and sort of just like think about it from first principles, it's pretty understandable.
Exactly, and I'm really glad you're on, and I get to selfishly ask you questions because, I read all the tutorials and it still doesn't quite make sense. And then even once you do it, you're still not sure underneath what's really happening. And so now that you're storing the text and this vector information, this latent representation, right? It's just a bunch of numbers in super high dimensions of like representation. Like for a while, okay, side note for our listeners, if you ever struggle with higher dimension thinking, I like to do a couple of different things. and maybe Jack, you can tell me if this is useful, because this is all you think about, right? Like, we understand one dimension, two dimensions, three dimensions. We live in three dimensions. Cool, got it. If I want to think in higher dimensions, I look at the corner of like a room, and then I use my mind to pop it toward me instead of away from me. And that would have rotated against the fourth dimension. Is that correct?
I mean, you know what? However works for you to visualize. Honestly, I don't even try to visualize more than three dimensions. You know, when I think about it, I just think about three dimensions, and then I think about the meaning of these things, right, and the distances between them, right? Because in the same way we can have distances between 2 points in three-dimensional space. Obviously, if you just add another dimension, you know, whatever, it's a different distance. But I actually think that's a clever way of visualizing it. For me personally, I'm just so in the weeds and in the math of it. I've never even thought that far.
Yeah, like eventually you do kind of give into the rigor of the math, right? It says, all right, if I have X and Y and Z, why can't I have another, Z2 and a Z3 and a Z4? The math all works the same. You just keep on multiplying. Um, but yeah, so back to these databases. You have this query, you go in, it grabs, like, does it pull back the actual text now out of the database? So you ask how to turn on the oven, and it's going to figure out instructions related to turning on the oven. And then what is the result out of Pinecone?
That's exactly right. It pulls back the actual, text, let's say the document about from the instruction manual of the oven, or whatever private data or public data you've uploaded to your context engine or search engine, we'll call it, and then it passes that on to the LLM, right?
Oh.
And says basically, here's the context, answer the question. And usually you don't even need a very powerful LLM for this oftentimes, because it's a simple matter of extracting, right? Finding the relevant little bits from the instruction manual and saying, here's what you do first, here's what you do second, here's what you do third. And so that's why the retrieval is such a critical aspect of the chatbot, because the better your retrieval quality, the better you're able to find the relevant snippets. You don't want to find the instructions from a different oven accidentally, right? That's the classic degenerate case. And in a lot of traditional search applications, if you just put a bag of words in there, you might end up with the wrong oven, right? Because it's just matching the words. It says, "Ooh, oven, this," and so having the right context, the correct instructions from the correct oven, and passing it to the LLM is in many ways the most important part of having an effective chatbot.
That does make more sense now, because I'm thinking through, all right, I'm building a chatbot. I have this LLM. It's just an API. When I hit that API, instead of the LLM having to determine exactly what to respond with, it'll make, well, the application will then make another call to Pinecone, and then Pinecone returns just what is necessary for the LLM to answer with. And therefore, it would be more efficient, because then you don't have to worry about fine tuning the original model, like the first model, right?
Exactly.
Which is expensive, which is crazy expensive to have to.
And not only that, but it doesn't work well, right? Like,
Tell me about that.
yeah, exactly. Research has shown that it's much more effective to pass the context to the LLM rather than try to encode all the information in the world in these, latent model embedding weights.
That's interesting. So now we're really talking about a different class of application, right? Like these knowledge things,
Hmm.
AI things, right? These,
Sure, exactly. Knowledgeable AI applications is what we like to call them.
a lot of the stuff that we've talked about and that is in general use cases, text based, right? Because we know we can manipulate text strings pretty well. And I imagine you could probably do like image search, right? If you broke them up based on groups of pixels or whatever.
Definitely.
And then, anything you could really chunk into. the vector space, right? Like,
If you can think it, you can embed it. That's the rule of thumb.
how should developers think about creating these vector spaces, right? Like, a lot of people now, I know for me, I'd say for me, and I'm a pretty average dude, we'll use the APIs. I'm not building stuff from scratch. I'm not a hardcore data scientist, but I know these things exist and I want to play with them. Like, how should I start thinking about data? And how should I start thinking about these embeddings and like stop thinking in terms of like JSON objects, right? Like all I think about is like JSON, but in this vector world.
Well, you're already thinking in 4D. You're way ahead of the curve.
I'll tell you another one while you're thinking. So what I do for 4D is like you take a piece of paper and you say like draw a square with only 3 lines, and you put like one line all the way across and you wrap it around itself to create parallel lines. And then you put two more horizontals on it, and you have a square in another dimension. Like,
There's actually a funny story about that. That's similar to a shape in mathematics called a hypercube, which is,
yes,
are you familiar?
yes, the 4D cube.
It's a four-dimensional cube, and it's funny because this was actually the original name of Pinecone.
Really?
Before, when we were founded, when I joined, we were Hypercube, and then we sort of went through a rebrand, decided it was a little maybe too something, and went with Pinecone.
Pinecone's a much more tech name than Hypercube. Hypercube would have been really fun, but
I'm glad you appreciated it at least.
so yeah, getting back to how should developers think about their data, and how do you wrap your head around this idea?
Yeah, so I think the best way to think about it, in my opinion, is pattern matching. This is actually how the human brain works, right? If you see a tree, like let's say it's a fir tree, right? You know it's a fir tree, even though you've never seen that exact tree before in your life, right? How do you know it's a fir tree? You're not doing it, it's not like you have a perfect picture of a tree in your head and you say, oh, this is exactly pixel for pixel the same, right? You're pattern matching. You're looking at sort of the outline of it, the sort of details here and there, and coming to a conclusion. It's the same with vector space, right? It's probabilistic. It's inherently fuzzy matching in some sense, and so it models the world in a much better way, right? If you have, this is exactly why you can use it to build like reverse image search applications, of course, right? Like if you have a picture of a pair of shoes and you want to find, what kind of shoe they are, great, right? Because what the vectors represent is sort of the shape, the color, the design of the shoe, and using Pinecone or another vector database to define the closest vectors in high dimensional space will show you all the other shoes that look the most similar, right?
Mm-hmm. Okay.
And then the same is true for text, right? It's that's why it's so great at capturing meaning and finding related content. The same is true, by the way, for recommender systems. Like companies like Spotify, Netflix have been using high dimensional vectors in some form or another to power recommender and saying, oh, this is similar content, right? You might want to look at this. E-commerce companies have been using this for years to say, oh, you bought toilet paper, here's paper towels, right? Or just drawing these implicit connections between information in ways that you couldn't with a sort of traditional database if you were just looking for like, oh, where equals toilet paper, right? And understanding the meaning behind unstructured content.
So it's a bit like, in a traditional way, if you wanted to search through a bunch of text, you'd have to apply some metadata, right? Like you'd have to apply some tags and then filter based on tags. So the vector embeddings, those are kind of like metadata tags that get sent in along with the text, is sort of like that,
Exactly.
but more fuzzy.
Right. They're like vibe tags.
Vibe tags, I love it.
So you have your like real tags, which are very useful for certain kinds of things. Like I want green shoes. Like maybe you want green shoes, or you want brown shoes, right? And you can just filter. Show me all the shoes that are brown. Show me all the shoes that are green. But sometimes like you don't know what you want, right? You're like, I want something that like kind of looks like this, right? And that content may or may not be tagged, right? You may not know that it's green or whatever, but using these vibe tags, fuzzy tags, or vectors, right? You can actually find things that are similar and in many cases are exactly what you were looking for without having to structure your data using the traditional metadata tags.
Okay. And so what is the process for I've got a whole bunch of catalog of movies, and then I want to turn those movies into a recommendation engine, and you have, say you're lucky enough to have user data and all these people watched all these movies. How do I start as a developer take apart this problem? I have a bunch of movies, I have user behavior around these movies. Now I want to build a recommendation system. What are like the high level chunks and pieces that I gotta think through to start to build this kind of a thing?
So I mean, you want to think about how you're going to train a model, right? And there's a lot of good research around training models for text. There's some for multimodal embedding that are getting popular. Copoly is an example. They use multi-vector representations. There's like ImageNet and some more research coming out on parsing PDFs and using latent. I think somebody used Gemma for training a specific model for representing embeddings from multimodal content. So see what's out there because the state of the art is changing really really quickly, and then figure out what your if there's something a model that exists out of the box that can just produce embeddings and you can dump those in a vector database and your problem is solved. I think for 99% of people that may be the case. And then you have more sort of bespoke applications, like a little bit like I mentioned, recommender systems. There's a few approaches like collaborative filtering. I mean, the concept is quite simple for training one of these models. You just need enough data, right? The concept is just you pass two things through the model that are similar, right? And then you measure the distance between the output vector embeddings, right? These latent representations, and you use backprop to train these to become closer, right? So that you obviously want things that are closer to be represented closer in latent space, things that are further apart to be represented further apart. So you have hard negative mining is a technique also used to train these models where you say, okay, these things are really different, I want them to be far apart. So then you pass them through the model and you push these embeddings further apart in an iterative way to basically make a model that has the space that you want.
And then Pinecone has its own like embedding services.
Mm-hmm.
Since the embedding model, I guess, is already done, you pass your data in and then it gets saved into the database. And then that's pretty much all there is, right? Like what are the fine tuning knobs then for once data goes into the database? Like the real fun begins, right? Like like now I guess now it's like the benefits of serverless, right? You're as a consumer, I'm not caring at all about the underlying infrastructure at all. I don't have any opinion on what hardware it's running on, right? And so where what am I now responsible for as a developer of this, as a maintainer of this vector database thing? I think that's definitely something I have no idea about because I haven't done this in production yet.
Yeah, for sure. I mean, the Pinecone embedding service supports mostly just text right now, and that's where most people are at, right? That's what most of the content is. And so for a vast majority of customers, it just looks like, dump your text through Pinecone embedding or our integrated inference API, dump it into the serverless database. It scales as you need it. If you're just developing, you're not going to be paying a ton because you just have a little bit of usage. And then once you go into production, will scale to fit your workload, whether it be high QPS, billions of vectors. All of these dimensions are handled without you having to worry about it in the database. And so, people are just really getting into production with this kind of technology right now. We're at this beginning of this curve. And so we're exploring a lot, like what you're kind of the questions you're asking, which are really good questions. Okay, like, if I don't see good results, how do I make it better? How can I, now my data's in Pinecone, cool, I can do all these searches, I can do these, fuzzy matching. But where do I go next? And so, these are things, look, this is still the beginning of what a vector database looks like. It'll look radically different in 5 years. And so I hope, I have more interesting answers to that in a year or two.
That is as interesting an answer as it gets, really, because for me, being on the cutting edge of the stuff, it's fun, it's dangerous, but it's still really cool, and I learn a lot. It's how we all learn as an industry, really. And even for our listeners who probably won't ever implement a vector database, they know that they probably could, and it's not that bad. And that companies like Pinecone, and I think there's other solutions out there that are open source as well. Or I don't know if Pinecone is open source.
We're not open source, but there are open source alternatives out there, and we will deploy sort of into cloud prem or on prem if people have those security concerns.
Okay, sure. That's even better to know with because as this type of technology scales, I mean, even when I think back about serverless, right? Serverless sort of people using lambdas for application logic was very sparse at the beginning, right? It was all about using lambdas to do like DevOps type stuff, automating infrastructure, tear up and tear downs. But then we started building applications with it.
I didn't realize that. That's actually really interesting.
Yeah, it really just took off because earliest lambdas, right? The original, it was just a way to do stuff to S3 because they built S3 and they're like, this is amazing. We can put anything behind a URL at whim.
It's still amazing, man.
Yeah, like that's the part that, I mean, as crazy as Jeff Cloud is, it's how I make my honest living. And, S3 in particular was really revolutionary, right? Like anything can have a URL. And then that URL can point to Parquet files. You're like, okay, fine. Like let's go.
Mhm.
And now serverless is a full application stack, right? We've gotten rid of the need to think about Ubuntu. And so with Pinecone here as an early thing of vector databases, like where else could it go? Because there's a lot of abstraction and like faith that a developer has to kind of give into probabilistic computing.
Yeah.
So I wanted to ask you next, what are you seeing in terms of like the approach and behavior of developers, because we want to build deterministic systems ultimately, but we're getting there with these probabilistic tools. And so this is also a little bit about like how do we maintain this long term? Is like, okay, I've got all these embeddings, it's giving me some answers. Products coming down and saying, we need to turn these answers into other answers. And all of a sudden you're like, well, that goes against the model we have to reach. Like, how does it evolve like that? Is like what is the conversation around that? That's what I'm thinking.
Well, when you're building probabilistic applications, you have to have a very scientific approach, right? You need to follow the basic method of analysis, right? You run some set of experiments on every single iteration. You expect some ground truth results, with some probability. You adjust for noise. You rely heavily on statistics. It requires a different, tool chain than just your traditional unit tests, integration tests, whatever. Okay, and so it's challenging. It's definitely challenging. I think that specifically, with something like Pinecone, we just aim to be as simple as possible to allow you to run, A/B experiments on top of it. And this is what a lot of our customers do, right? They'll run with a new embedding model and then they'll dump it into a Pinecone database and do like a 20/80 split or 50/50 split. Roll this out. This is the kind of experimentation that you need in order to actually operate probabilistic applications, at scale.
That is awesome, actually. Like That is such a great answer because I've been asking myself this question, and I've been asking other people this question. Is like the LLM, it's gonna do what it's gonna do, and you can influence the inputs, but only influence the outputs by so much. But if you do approach it mathematically, you can put boundaries in place.
Yeah, it's you can try, and at the end of the day, you need to have the right metrics and KPIs and let those speak for yourself themselves, right? Because you are building a probabilistic application, which means you're going to put this out in production, and who's to say it's in the desired state, right? Who's to say, this iteration was better than the last iteration? So you have to have metrics that say, okay, the users click through at X%. The users, if they continue their conversation, okay, they probably didn't get the answer they wanted, which means, that's a ding against the model. And so if you constantly gather these metrics, perform rigorous statistical analysis on it, then you can actually sort of answer the questions that you're asking. And this is what we see, by the way, most customers do, right? Like customers are not coming to Pinecone and saying, hey, we need vector search. We know exactly what it's going to look like. We're going to embed it in this way. We're going to deploy to production in this way. People come to us and say, hey, like we have a hypothesis. Like we think if we use vector search here, it'll, improve our click-through rate. It'll improve our engagement, and our time to resolution for these, tickets or something like that. We're going to run an experiment. So all of our POCs are really in the form of, many of them are really in the form of an experiment where the user is tracking some metrics on their side, some KPIs about some business metrics, and they're using Pinecone and sort of the ease of prototyping with Pinecone to validate that those metrics are actually improved by, vector embedding search.
Yeah, that's a good approach because as an organization, you have to put some kind of measurement on this effort that you're doing,
Mm-hmm.
no matter how experimental or wild it may be. You have to inspect what you expect. So you have to put those numbers down somewhere.
Yeah.
Well, that's pretty cool. So, are there any like breakout use cases? Is it just the text search, or like something that's in the last, I don't know, year that you thought was like, wow, I never thought we could use a vector database for this?
Yeah, I mean, we have a few people in the biotech space using it for like drug discovery,
Yeah.
like protein matching. I know people have used something similar for DNA search. So basically finding like relevant patterns for drug research or genetic investigations. But it's endless. Like the possibilities are really you just your imagination. I think I would love to see bigger adoption in the security space. I think like matching, like logging, network events, like anything that's happening in the security space for anomaly detection. Vector search is a great fit for that. Spam fraud detection, we see that a good amount actually. Like sort of finding checks like or accounts that are fraudulent
Mm-hmm.
because those are sort of pattern matching problems.
But make a vector database to detect whether or not something is generated by AI. I've been seeing some really interesting content out there that's AI, it's like AI generated, but it looks so good. It looks so clean. But then me as a human, again, going back to pattern recognition, when I zoom out on, like, say I find a page, it was a page of like recipes, and it was clearly just this blog of all generated stuff, but it looked possible. But then when you look closer, you're like, oh, that there's like 4 layers of quesadilla inside of this hot dog somehow. And when you zoom out on it, they're all the same color palette, like the same camera angle, the same proportions, and you're like, ah, this is made by AI. But there's no way I could think of how to tell tell vector database, like tell Pinecone, like these are all AI and these aren't.
Yeah, I mean, look, you could try something naive, right? Like you could just take all those AI generated images, right, and then embed them with like ImageNet or some off the shelf image embedding model, dump them in the vector database, and tag them as AI, right? Take a bunch of images, from your phone or the web that are real images, right? And then dump those in the vector database and tag them as not AI, right? And then every time a new image comes in, you do a search into the vector database. You get the like 10 nearest images. If most of them are AI, you think, hey, that's probably AI. If they're not, then maybe it's not AI, right? I don't know how well that would perform, but you can actually build classifier applications like that with a vector database pretty easy.
I think that sounds like a blog post I gotta write.
You should try it, man. I can't promise it'll work, but you'll learn a lot at least.
Oh, for sure, for sure. Since this is talking serverless, I feel like I gotta talk about the cloud native architecture and distributed nature of Pinecone, right? Like, so Pinecone isn't something that you typically host yourself, right? It's serverless, and you get an API, you get your API key, you can call in to do things. What else about the architecture, like, do developers need to really understand? Like, are there any primitive objects or features or things about Pinecone that we should think about?
Yeah, for sure. I think that the main thing to think about is that writes and reads are decoupled. So, this is common for lots of serverless databases like DynamoDB or anything like this, right? What we charge differently, we think about them differently. And they're going to, you have to shape your workload ahead of time just to understand the cost, right? To say, okay, I'm ingesting, a million vectors every minute, right? Or I'm like, because I'm updating them all. Like every minute, I re-embed my whole database. This is, of course, a little crazy. I generate all the new embeddings every minute and I, update them all. Okay. This is actually going to cost you quite a bit because, we build indexes based on the geometry and the shape of your embeddings. And so when you update them, we have to rebuild the indexes, right? And so, this is one case where customers might be surprised by the cost or something like that. But in general, if you just, talk to us and we can figure out a solution, make sure that the index is tuned properly and that you're not doing something you shouldn't be doing. Like if you, some people will update the whole thing when they really just want to update one field, or things like these best practices that if you talk to the team, we can help make sure that it'll minimize your write costs. And then on the read side of things, obviously serverless is a myth in some sense, right? Because the elasticity of the cloud is an illusion that we give. And so if people are scaling up from, a tiny, one or two queries per minute, and then they're going to like 10,000 per second or something, wild, you're going to hit rate limits. We have rate limits in place to prevent that from impacting other customers. And so, we have solutions for that. If you want to be on, reserved or provisioned capacity, and ahead of time that your workload, hey, we're going to prod, this thing's getting real traffic. We'll work with customers to make sure that the resources are provisioned for them to be successful.
Okay. And Pinecone's designed to be sort of like real time, like you can do real time query response, like through a user session, right?
Yeah, exactly. It's not asynchronous. We do have like a bulk import API. This is another thing we'll encourage users to leverage if they have a lot of data they want to get in. But in general, it's an interactive API, a REST or gRPC API. You put some vectors in, in near real time, you see them reflected in your database. We have some asynchronous processes that actually index this data, build more complex representations of it. But from a user perspective, it's sort of opaque to them.
Okay. Very cool. Very cool. And um, are the folks that you're working with, it sounds like Pinecone is still very much working directly with customers to build out like how this database is supposed to be, like, do its thing. The tool sets are really developing. We have this core idea of storing all these vectors, being able to correlate them, being able to pick them out in this shared probability space, and then do fun things with them. But it will need all kinds of different tooling, different observability, different monitoring, how do you inspect errors out of it? Like what is an error out of a database out of what is an error out of Pinecone even look like? Because it's will it throw a type error? Will it throw an undefined? Like all those things still happen?
Yeah, I mean, if you use the API wrong, certainly, but the bigger concern, right, is the silent errors. Like if your model is hallucinating in some sense, or you get results back that are not what you expected. So yeah, we're doing a lot of research. We're publishing a lot. We're going to conferences, talking to people, presenting work in different directions, and collaborating with other companies in the space to try to solve these problems through partnerships or either rolling our own solution.
Nice. I have been saying for a while that the future of serverless is databases. It's one of the things that I think could always be improved upon.
Yeah.
And the other thing about databases is it's time to diversify. Like your modern workloads are so different across all. Like you're going to need DynamoDB, and you're going to need a SQL thing, and you're going to need a BigQuery type columnar giant thing when you do big data analysis. And then now you could also lean into these vector databases for your AI agents and stuff. And it's really about picking the right tool, right, for the right job. And it's not going to be a single database that rules them all. Like it just can't be anymore.
Yeah, I mean, we already see that, right? Look, I mean, there's been countless databases that have come out of nowhere and had a huge impact, from MongoDB to, Elasticsearch to, Cloud Spanner. People are using that a lot on Google. It's got some good features, DynamoDB. All these databases are different, you know, different and useful for different things.
Yeah, I mean, even AWS released. It's in preview right now at the time of this recording. Distributed SQL, DSQL.
Oh, cool.
They rewrote their own um, database engine for SQL using it's Postgres compatible ish, and they've made it very serverless in the way that I can interact with it, how I interact with DynamoDB. Like it's pretty cool. It's still in preview, and I think it's just another case where the needs of developers are becoming so specific and so niche to solve these very specific, very niche problems in an effort to serve organizations with even more and more niche domains, right?
Yeah.
And it's to me it's wonderful because well, we still have work and we still have jobs and we still have reasons to try new things.
Yeah. Couldn't agree more.
Awesome. Well, man, it's been so exciting talking to you for like the last hour. I don't want to take up too much more of your time, but at the end of every show, I like to get down, get serious, and have a real heart to heart and get your hot takes on a question. And for you, that question is what is an item under $20 that you can't live without?
Wow, I wasn't prepared for this one.
Now you're searching an extremely high dimensional space.
You know what? There's this gum, this like Turkish gum that I've gotten really into. We chew in the office called I think it's called Talim or something.
Okay.
It's totally flavorless. It gets like it takes a little while getting used to. Or Falim, that's what it's called.
Okay.
And the first time you chew it, you're just gonna think, "What the heck is this guy talking about?" But it's really addicting. The texture, it's really good for your jaw, and I just need it while I work to focus.
Okay. Nice. It's the antithesis of the Zen bro. Like, let's go.
We got a few of those in the office too.
This is fascinating. This is amazing. Thank you so much for bringing this to my life. I didn't know I needed it. It's very, very awesome. Well, Jack, we've talked about a lot today. We've talked about the fourth dimension. We've talked about just building some software and thinking about how we can use vectors to solve our problems and to give in to the fuzziness of the universe.
Yeah.
Before we go, is there where can people follow your work? Give a shout out to where people can find you.
Yeah, follow me on Twitter, Jack underscore Pertschuk, Pertschuk, for more hot takes, recommendations on products under $20, musings about serverless and algorithms. And yeah, stay tuned with Pinecone. We're constantly launching products, and reach out to me if you're interested in trying something new or you have any ideas for how we can improve the platform, or you just want to chat. Always happy to connect.
Brilliant, brilliant. Well, folks, that's it for Talking Serverless today with my special guest, Jack Pertschuk from Pinecone DB. Today's episode is sponsored, as always, by Serverless Guru. And Serverless Guru, we help accelerate your journey in the cloud. If you have any questions that you have been thinking about cloud wise, give Serverless Guru a shout. You can even give us a shout directly through this podcast, which reminds me, please subscribe, leave a like, leave a comment. Even if you hate it, all the engagement actually works. So that's it. Thanks so much, everybody, and we'll see you on the next one of Talking Serverless.